Okay, guys, we are going to do this lab today. And it's broken down into parts, and the changes refer to physical and chemical changes. We are just trying to do some observation into that. And this experiment is broken down into 5 parts. I've actually already started one of the small parts of this lab, and it should go pretty well for us as far as that goes. So the first part, obtain the mass of the evaporating dish, cube together. Well, I didn't use an evaporating dish, I used a beaker. But just to get it started, because it takes quite a while, I went ahead and did this one without putting it up there. The mass of the ice cube and the beaker together is 115.63 grams. I will also give you this data at the very end. 115.63 grams. That's going to continue to build to the very end. Okay. Next, we're going to do this same thing with the candle. And the candle is sitting on a watch glass. Okay, I have to turn the balance on. And what we're going to do then is light the candle, let the candle burn for a while, and mass it a second time. So I'm going to go ahead and set it under and zero it out for us. Our mass of the candle and the watch glass is 101.43 grams. Okay, 101.43 grams. And we're going to go ahead and light the candle. So I'm going to take the candle off the balance and light it up and let it burn for 5 minutes. So what we're trying to establish is what's the difference between a chemical change or a chemical property and a physical change or a physical property. Okay, so there's the candle. It's going, it has to go for 5 minutes. Next, the magnesium ribbon part. Now this part, be careful of. It gets to be very bright. And we'll burn this for you. Be careful. Not too directly up. I'm going to light it here. I have actually in my Bunsen burner behind my computer. See that part. I'm going to bring the piece of. This is what the ribbon looks like before we start. It's just a small piece of water on, and it takes a bunch of hot. See how incredible it is. It under the sink. Okay. Okay. So the first part of part 3 of that lab, to see what happens when magnesium ribbon burns. The second part, I'm going to get a test tube. Excuse me, I'm going to shut. Someone doesn't bother us. The second part of this is we're going to get a second piece of magnesium ribbon from my piece of magnesium. And here's our magnesium ribbon. Okay. And then I am going to put 5 milliliters of 1 molar HCl. So the 1 molar HCl is in this. Okay. And I'm going to grab a graduated cylinder. And this is a 5 milliliter graduated cylinder. So I'm just going to fill this all the way up to the top. And to tell the truth, for this lab, it doesn't matter if we're exact. We're pretty close. I'm slightly over, but that's going to work for what we need to do. So I'm going to put this in my test tube, which I already cleaned out, by the way. And it looks something like this. Now, what's going to happen is I'm going to put my piece of ribbon in here, and I want you to watch and see what happens, and you record your results. And go into town. And we'll let it go for a little while. And I shake it just to keep the magnesium ribbon down in there. It actually speeds it up because it gets the acid onto the ribbon. It's slowing down. It'll continue to react slowly for a while, but there's what happens with our piece of magnesium ribbon. Okay, so that's experiment 3. Record what you found happening. Okay, number 4, we are going to mix silver nitrate with some hydrochloric acid and see what happens there. So I have a second test tube. Instead of using a pipette for this part, I'm just going to use these dropper bottles we have. So here is my silver. This is a 0.1 silver nitrate solution. Okay. Cap like this on your little dropper, you don't want to set the cap down. All I'm going to do is count the 20 drops from here. There we go. 20 drops in there. Once again, if we're in the ballpark, we're probably going to be fine. 0.1 molar HCl. Now watch for any kind of reaction. Continues to go for a little while. And then shake it, and you can see what happened. There's actually a lot of little pieces left over. So I'm going to put this, I'm going to move our magnesium ribbon going back to the back, and I'm going to put this one here. Okay. The next thing we're going to do is actually filter this out. We do a filtration, that's called a gravity filtration. I've already prepared a piece of filter paper. This is what we call fluted filter paper. It's just a normal piece, and then you just make the best crease you can on this thing. Okay, and you go ahead and put it into the funnel. And what I always think is a good idea is to get this thing wet, and that keeps the filter paper sort of sticking to the funnel for us a little bit. So what I'm going to do is something you're going to notice if you look really carefully at this. Hopefully you guys can see that. At the bottom, there's that little white powder, it looks like, that collected. That is the precipitate. Precipitate is what happens when we mix two liquids together and we get a solid forming at the bottom. It falls out of solution, we say. Precipitate. Okay, we have precipitation. What I'm going to do is go ahead and filter this. And I left a bunch of my white stuff in the bottom. What I'm going to do is use a little bit of distilled water, spray that in there, try to get it to come through as best as I can. And there, the test tube is empty, so that should work exactly how we want it to go. Okay, we're going to let this filter for a little bit. Gravity filtration does take a little bit of time. Okay. Next, before we do anything else, let's finish the candle. So I have to blow this out. All right, we want to mask the candle a second time. So we'll let it go until it comes to rest. So this is our mask after 100.90 grams. So I want to repeat. When I started burning the candle, the mass was 101.43 grams. After 100.90 grams, mass was lost. If you see mass being lost ever, that should be indicative of a chemical reaction. A physical reaction should be on the opposite end, and I think, yes. Take this off here. My ice cube is now melted, and you can see no ice cube left. There's just there. I can find the mass of this also. And I got 115.59 grams. So that is the mass of the water in the beaker. If I'll recall for you, the mass of the ice in the beaker was 115.63 grams. We lost a tiny 0.04 grams, probably due to evaporation or maybe a little spill or something like that. Okay, this is more considered a physical change, and here's the easiest way to tell the difference. A physical change can be easily reversible. In other words, I could take this, if I put it into the ice cube maker, it would freeze and make ice. I can change this and put it back to what it was pretty easily without using up a whole bunch of energy. Theoretically, if I had this handle, if I could capture all the smoke that came out here, any wax that came out and spilled or anything else, theoretically, I could put it all together and remake the candle. Theoretically, it's going to be pretty tough to do, and it would take an enormous amount of energy compared to what we did with the water. This would be considered a chemical change. Notice though is we had smoke coming out of the candle at the end. Okay, you can have chemical changes and physical changes happening at the same time. So there was a little bit of physical change happening too, but the main thing we were looking for was a chemical change. Chemical changes generally something happening almost in all of them. Atoms are rearranged. That's the definition of change. Physical change, generally speaking, the atoms stay in their same arrangement and they can put back quite easily. When we have a chemical change, though, you actually remove some atoms and put them with something else and change the physical nature of the substance. We no longer have the original wick that we had. Some of it burned off, some of the wax burned off. We can't collect that back. Like I said, technically you could, but it would take a lot of effort. So it's just not something that happens. So generally speaking, that's a good example of a chemical versus a physical change. So to finish this off, I think this is pretty much true. Okay, we've got the little bit of liquid down here. And you can see this liquid, by the way, after you filter something, is called the filtrate. The liquid is pretty much clear, okay? If I show you what's in here, you can see that solid stuff that's left over. That's silver chloride. And we took silver acid, and the silver gets the white stuff that precipitates out of the solution. So that's what happened. The last little part of the lab is just a fun little part. This is where we take a penny and see what happens. And we mix it with a little bit of vinegar. So we've got to watch over here, get that penny, and got to get some salt. Now you guys at home can do this lab pretty easily yourself. Okay, just take a little bit of salt. I have my water in here, so I'm just going to dump that out. It's not going to cause an issue. Okay, I'm going to measure out some vinegar. Okay, that's what I have in here. We're supposed to go 20 milliliters. I'm just going to pour a small amount of vinegar into my beaker, roughly 20 milliliters. More. There we go. Then I need to put just a pinch, a small amount of salt. So I've got salt here. I'm just going to take my scoopula and get that salt, drop it right in there. Before I do anything else, I like to swirl this to try and get the salt all dissolved. Now we're just going to drop the penny in. And I'm going to swirl this up. I probably should have shown you what the penny looked like before. Up. Let me grab another penny. I think we have enough in there to do it twice. So So by penny, you know quite all. All right, that's what this one looked like. Let me drop this one in here. And if we swirl them around through the action of the salt and the vinegar, and a little bit of time, I could put a touch more salt in here. Pour these out. Those pennies ended up becoming pretty shiny. Don't do this because it the material off, but it makes them quite shiny and cleans them up very well. Excuse me. So what you're supposed to do now with this is upload this experiment to Notability. Okay, then you go ahead and obviously you've watched this through. And what you have to do for each of the parts of this experiment, I want you to determine whether you have physical or chemical changes going on. And so to give you hints about that, think about, could I put it back to how it was pretty easily, with not a lot of effort, without a lot of energy? Okay, despite what the lab says, all I want you to do, I want you to include a data table, and I'll show you the data again once more. Okay, and then I just want you to write a conclusion in this lab, okay, and follow the directions for the conclusion. It's pretty straightforward, okay? Restate the hypothesis and follow that, and you'll get what you need to, okay? Once again, there is our data table. I'm hoping you can see the data pretty well. I'm going to read it off once again. The mass in the ice of the beaker is 115.63 grams. The mass of the water in the beaker is 115.59 grams. Mass of the candle before being lit is 101.43 grams. Lit is 100.90 grams. There is the changes lab. I hope you got the data, and you can go ahead and follow this through and get it done. Thank you very much.